Hello everybody and welcome back to the next part of this series. In the last episode we imported some audio material, set up our landscapes with the landscape material, exported or re-imported our height map, and we created some UMG widgets for our map. Now let's make use of those assets and we deal with the footsteps first. We go to our epic folder, and this is not something we would set up in the third-person blueprint, in our character blueprint. So we would not check out the movement states and then make changes or play sounds according to that. No, we do that in the animations part, and that is in the mannequins folder under animations. You will see all kinds of animation sequences. We also have a blend space in there and an animation blueprint, and that's what we open up. Now we go to the animation tab here on our screen. And here we can update our animation with the sounds. We open up this little dropout box and we select the animation for which we want to add some sounds. Let's take the run animation first. We can see it here in our preview window. Our character is running around. We see the timeline at the bottom, and we can see here just an empty field of notifies with currently no notifies in them. And those notifies are basically what will trigger our sound to be played. So we just start at the beginning of our animation and just pinpoint the moment where our character foot is touching the ground, like here. Then we right click in the notifies field and say add notify, and we play a sound. Then we go forward in our animation until the other foot drops down, and we add another notification, play sound. At the moment we are not terribly concerned with naming them or anything alike. In more complex animations where you have multiple sounds maybe going on, then it's a good idea to give them some other names than just play sound. But for now we're sticking with that. The sounds we're gonna play, we create first. We have our wave files, and now we create another subfolder in our audio folder and call it cues. And inside that we create another asset, a sound asset, a sound cue. And we call it footsteps sand left, because we want to have different footstep sounds for left and right foot. So it's a bit more variety than just having a normal sound that plays all over again the same. So what we're gonna do in this asset here, we put in our different footstep sounds as a wave, and then assign the sound wave. Make sure we have it selected, and if we connect that to our output and play our cue, we would hear exactly that sound. So we add our second one. Cannot drag that in. We have to do it this way. And now we can combine them with a random node, and this is gonna pick randomly either one of the two sounds, and then that will play on our notify. So we play the top, bottom, top, bottom, top. At the moment it seems it's just alternating between it. So now when we hit play cue, it just picks one of those inputs. We can set a weight, what we want, if we want a certain preference to a certain output. So here it goes like this, and if we say optimize without replacement, then it would basically pick all the sounds from these inputs until they were all played at least once, and then it would start all over again. So with just two sounds in there, it would basically just alternate between those two. So we deselect that, and we have our random inputs. We save that out. We close that, go back to our cues, and why are we on the physics tab? We create another copy of it, and we just pretend that we had some different footstep sounds for the right foot. Later, when we have more footstep sounds, we can easily replace them. So at the moment we don't care that they actually sound the same. So we go to our first notify and attach our footstep sans left. So it already takes the name of that sound asset as the notify name. If we click in our notifies bar with the right mouse button, we have also manage notifies. I don't know why they are not showing up here. Normally they would show up here, and we could even rename them to something that we like. I have to check that out, why that is not working. We can also set a different color for our notifies just to have them organized. For the moment we just leave that. We can play our animation. Of course this now sounds a bit weird, but it's just the test sounds that we have. We go to our walking animation, and going through that we are basically doing the same thing. We have the right foot down, we add a notify, play sound, that's the footsteps right. We select our other asset, wait until the left foot is down, just about here, and we add a notify, play sound, and this is then our character walking across the ground. We close out our animation blueprint, all those subfolders, and try that out in game. Of course this is going a little bit fast and a bit too repetitive since we only have two sounds. Let's change something to the way our character walks, because when we want to sprint we also have to walk, to make it different from sprinting. So again we first attend to our mannequin, to our animation blueprint, and here on the animation blueprint we also have a blend space. It's a bit misleading here. It's called third person idle run 2D, but it's actually only a one-dimensional blend space. And what this one-dimensional blend space lets us do is from all these animations that we have here, where we set up our notifies a moment ago, we have them here as sort of points in a gradient that is tied to a variable. Here the variable is the speed variable. That's the one you see here, and that's for each animation that we have. So this would be then the walk animation, the walk speed. This is the running speed, and this is the normal slow-paced walking speed. And it's going back to our idle. So if we gradually increase the speed of our character, it will not jump instantly from idling to running, but we have this blend over in between. And here we can dictate where those values are. So at the moment we have the third person walk animation fully blended in at a speed of 93. The idle animation, of course, is at 0, and we're sprinting fully when we have 375. Everything below 375 and above the 93 will be then a blend of our walking and the full power sprinting. So this is then a bit slower sprinting, still a bit slower, and this is then the pure walking, and then we go to the really slow senior citizen walk, and then we go to our idle animation. At the moment I leave those values here as they are. We're gonna change in our first person character, in our character movement component, we make some changes to some of the default values that are in here, because the template comes with values that make the character basically run and sprint from the very beginning on. So when we take a look at our character movement down here, we see that for our walking, the speed set to 600, that is way over the 375 that we have for maximum sprinting. Even the crouch speed comes close to that. So we set the max walking speed at the moment to the 93.75 or something that it was when we have our walking animation. We compile that, and if we go now and hit play, then we're walking a lot slower than previously, and we hear some footsteps that now sound a little bit more realistic. Still not perfect. So that was that part. Now we can walk, and we are no longer sprinting by default. Now I would like to set up this this UI input a little bit better, because we're going to do the same thing for our sprinting. At the moment our inventory summons at the press of the I key, and this is pretty hard coded at this point, so we cannot make a menu in our game at this point to say the user can change the key configuration, or we could not even map it to a specific button on a gamepad. So we're gonna change that now. We don't want the I key per se to be the action that that triggers our menu, but we want to have that set up in a more generic way. And the way to do that is by our project settings. Here we have a lot of categories, and one of them is input, and we are interested in the action mapping. There are action mappings and axis mappings. Generally the axis mappings is for inputs that are in a range, like the direction. +1 for moving to the front, to forward, and -1 is moving backward, down, and intermediate values could be basically translated then by a partially tilted gamepad stick or something. Of course, when you use the keyboard, you always have those full values. And the action mappings, as you can see for the jump, that's basically tied to a key. It doesn't have a range, so it just executes or not. And the same way that is set up for our jump, we gonna add for our inventory. So we add another action mapping. We call it the show UI action mapping, and we choose a key for it. And we just take by default the same key I. No shift or other additional keys required. And now when we right click in our graph and enter input, then under our input action events, we see our show UI action mapping. And this does then basically the same thing as our I key, with the difference that we can manipulate this action mapping now at runtime, and users can choose different keys for their actions. So if I hit the I key, I still get my inventory and attribute screens and all that working out. And if I would now want to change that, all I have to do is go into my action mappings and select a different one. The same way I could make another key, then the spacebar my jump key. And the same thing we will set up for our sprinting. And before we do that, we go into our UMG folder, because now I want to make a little bit more work on the minimap that we started last time. We created the widgets, we created the material, we added it to our screen here. And the way this works is we get the world position from our character and have some indicators in our map, 2 to be exact, to tell the map bounds, and we calculate our player position relative to these map bounds in a from 0 to 1 scale, pretty much like a UV space, if you will. And when we have that, then we can map out our position also in a 0 to 1 range inside our map. So even if we have a square map and a non-square map image here, we would still get accurate references. In this case, the dot would just move faster in the X direction per unit in the world than in the Y direction. But later in the game we can match the shape of our map to the shape of our playfield, and then that will be consistent in both dimensions. So how do we do that? What do we need for that? First, we need 2 actors to define the bounds of our world. So in our UMG folder, we create another subfolder and we call it actors, because that's the actors that we implement that are related to our UMG stuff, because that's not something that would show up during gameplay or during game. It's just an asset related to our UMG logic. So in that folder we create another blueprint class. We choose actor because we're gonna place it into our level, and we call it map beacon BP for blueprint. Then we open it up just to have a visual reference at design time. We add some cylinder components but not scaled like this. Maybe more like this. And we pull it up slightly because we're gonna set it firmly on the ground. And just to be fancy, let's add another little sphere to that. But not attached to the cylinder because we want to have it normal dimension. Well, not that big. Maybe like so. And this will define our map points. So if we take one and drag it out in the level, at design time we can see where we place it, and that this represents one of the borders in our map. So we need a top left and a bottom right one, and we leave it basically as that. There's not any code or anything going into them. They are just used for a positional reference. So let's take one and place it here, say on the top left of our map, somewhere here at the corner. Doesn't have to be precise at this point. And we alt drag another one out to the bottom right corner. Let's put it up there. And now we name them. The map beacon 2 will be the map beacon bottom right, and our other one, this one, will be the map beacon top left. So now that we have those in our level, our actor, who is owner of our widgets, needs to know something about them. So the widget can then tell, based on the player location, where on the map he would be. So we have our third-person character, and he exists in the level, and he has all these widgets. And how does he access them now? There's no way, or we could make a find all actors of class and then choose our map beacon blueprint to filter out all the assets. But I like to work with direct references, the same way we set up the buttons for our menu widgets. It works essentially the same. If you remember, in our UI panel widget, we set up those bindings here, and we did it here because this was the place where we have access to our buttons, where we can get the references, and we have access to our individual panel pages. So the same way, when we now want to have our actor and our beacons talk to each other or know about each other, they also that needs to be set up in a common place. And that common place for a level is the level blueprint. We open up our level blueprint. We have the same nodes as usual, except for construction script. Those references in a level blueprint that we want to set up, The earliest we can do that is in the event begin play. And for that we drag our references from the world outliner to our map beacons into that level. And now we have to get a reference to our player as well, but a normal player start here will not do. So what we do instead, I put that away for a second. We go into our level and delete our player start. So when we hit play now, we still see something going on because there's a default player that we have in there. But we take our third person character and place it in our level. Put it up fairly in the center, and if we hit play now, we'll see that we have a twin. Yay! We're no longer alone. This is because the player, this character here, we need to possess it first. We go into our player, and if we're too lazy to search, we just hit possess in our filter and auto possess player. We make it simple, we keep it simple. We set that to player 0. And if I hit play now, no longer a twin there, and this is the player that we control. So back to our level blueprint. Let's take our third person character, drag him into the level. And now we have our ingredients, what we need. We have the third person character, we have our map beacons, and now we can make them talk to each other. There are several ways to set this up now. We could give the map beacons, we could give that character just a reference to the map beacons and have that passing on to the widgets and let the widgets figure out how to calculate things. And so basically we first need for our map widget some sort of logic or functionality to make up these calculations. So we go to our map widget and we will assign those beacon blueprints here as a variable. That's what I just decided to do. So this is a new variable type, and we call it top left beacon, and it's of the variable type map beacon blueprint, and it's a reference. We create another one for our bottom right. And that is there. Then we go to our character. And add them here as a reference first, and then pass it to the widgets, because when we try to access the map widget from the level blueprint, I think, if I'm not mistaken, the level print runs before any of the construction events or any of those events that any of those begin play events that we do here in our character. So to be on the safe side, we just create some permanent variables on our character. They always exist, and then at the appropriate times we pass them on to our map widget. So just make this a bit bigger. we create another, and we call it map beacon top left reference, and it will be a map beacon reference. And another one, like so. And in our level blueprint we can set them. First we set the top left, and the top left will be our map beacon item. And now we this time I'll drag a wire out, I don't duplicate the node. We set the bottom right reference to this one. So now at begin play we have our references set to our character, and in our third person character we can now process that further. The best way to do it probably is the build UI component, where we set up all our widgets. So we create an additional branch underneath here and get our map widget that is deep in our UI panel widget. So we do the same thing as we did for the attributes widgets. We're gonna get us a shorter reference for that. So we have our UI panel widget, and then the body panel, and the map page, and the map widget, which has then which will then have our variables here, like our top left and bottom right beacons. So we take that, promote that to a local variable, we call it local map widget reference. Oops. Like this. Connect that up again. And now we setting the top left beacon to our top left reference. And we do the same for our bottom right. Yep. I get now this what we want. So now when we hit play, everything should be working as expected. But if we exit play, then we see, yes, immediately some errors thrown. And this is because when I set up this local reference, this UI panel was not created yet. We created here further down in our sequence. So it means when we create it here and update it, then any node that holds a reference to that will not hold its data until that set was made. So we have to disconnect that from here. And add it here to the end, to a point after which we set this reference, so we can get the other reference from here. So if we hit play now and return from the game, we don't see any errors anymore. So always make sure when you're using such local references to get some values that you created earlier, that you only reference them after you created them. So the next thing would be to make our map use that information, to make use of those values in here, but we're not gonna do this in this episode. This would be then something for the next episode to continue working on that. So today we covered audio cues, some animation notifies, and set up some action mappings. And the next episode we continue with that and then start making our character actually sprint. See you then. Bye.